Hello, I am Alexis King. I, until about last year, was working on the Haskell compiler, but now I'm writing Scala at a company called August Health. I think probably the thing I'm most well known for is I wrote a blog post called Parse Don't Validate all the way back in 2019. It's a little scary to think that it's been that long. Today, I'm going to be chatting about just a fun side project that I've been working on recently, which is a Nonogram or Picross implementation in Racket, which is my favorite functional programming language.
Can we start with a hot question? Why is it your favorite functional programming language? Do you have any, like something that others miss or some killer feature?
So there's a variety of things that I really quite like about Racket. One of them is that it's not really a single programming language. It's been described as a programming language. It is something that is intended to be extensible, so you can add new language constructs as a library. Pattern matching is just defined as a library in the standard library. And you can also define your own custom language, which in Racket are called hashlangs. For a while, I was working on something called Hacket, which was like Haskell and Racket. Haven't been working on that for a long time, but there's a lot of very interesting things in it. And there's a domain-specific language for writing types, like type systems and little type languages where you write things that look like typing rules and things like that. There's all this just cool stuff in it. But then it's also it has a lot of very useful libraries. And I think that's one of the things I'm hoping to illustrate with this particular project is that even though it's this weird little research language, and I admittedly probably wouldn't use it for serious building application software just because there aren't that many people that write Racket and the ecosystem is small, but you totally can. And it has a web server, it works fine. I've written my own little personal projects in it. I just think it's neat. I think there's a lot of things in it that don't exist in any other language.
And also, the blog post is in Racket, right?
Yes, my blog is actually, so this entire documentation system, I think, is actually one of the sort of crown jewels of Racket. All of this is a Racket language called Scribble, and I can show you a little bit of what the source code for that stuff looks like, but it's this document preparation system. It's like, you can think of it as being similar to LaTeX, but it renders to PDF, but it also renders to HTML. And it can be used for writing documentation, but it looks a lot like LaTeX. But unlike LaTeX, which is just this miserable tower of text macros, this is actually a functional programming language. And when you write something like this, it's just a function call. It's a different syntax for a function call for a function named title. And so it's a nice functional way to build up any kind of document, but it's used for all the documentation. And so Racket, as a result, has, I think, some of the best documentation of any programming language I've ever seen. And partially that's because it's also used in education, I'm sure, but it's really neat. And if I open up just my code here and look at anything, I can just say, yeah, show me the documentation for this, and it will take me to it. And this is actually just on my local machine. And it's very detailed, everything's cross-referenced. So very neat.
Yeah, just a one page looks like. I don't know, the equivalent of 20 Haskell packages, right?
Yeah, yeah.
Mutation.
Yeah. Now, I guess
Wow.
one other thing that I'll say real quick is that Racket, it's a scheme descendant, so it's a Lisp. And so if we look at this, like this is written in the Racket language, and so it does have lots of parentheses, and I know that turns some people off. I don't really mind syntax that much. I certainly think it matters a little bit, and I don't love S expressions. I know that some people have a particular fondness for them. There's some things that are nice about them, but I think all things considered, Haskell is my favorite language syntactically. But there is this in progress, like it's still early enough stages, but they're working on kind of, it was originally called Racket 2, but that was a little controversial. So they've renamed it to Rhombus. And it is supposed to be, here, I want to look at this. It is basically giving it a more kind of Python-like syntax, and it has a lot of additional features as well, but it's this new project that they're working on. So maybe someday this get to a point where it's as feature complete as Racket, but there's a lot of cool technology in here. They support all the fancy macro technology, even though it's not S expression based. So lots of cool stuff in the Racket world.
And is that kind of like a different front end for the same language then?
Yeah,
Or is
I think that's a
it,
good
yeah.
way of thinking about it. It's like Racket has, I get into this a little bit, but like the way that Racket works is that there's an underlying core language, which is called the kernel language. Actually, this is not, oops, Will that take me? No. Fully expanded programs. That's what I want. Oh, no. None of these are what I'm looking for. One sec. There's something in here, which is, yeah, here we go. Fully expanded programs. So this is their core language, which is very minimal. It has if, lambda, let, again, not much else. And so everything else in your program is macro expanded down to this core little tiny lambda calculus. And so when you write any language, including the Racket language, like I can actually click on this button, and this might take a second because this is a very large module. I should probably have done this on a smaller one, but oh boy. It has 9,216 macro expansion steps, and it eventually results in this completely unreadable core language gobbledygook. But this is what actually happens. And so Rhombus is something that expands down to the same, eventually expands down to the same core language, and so they can interoperate with each other.
On the other end, because I've heard that you compile, I don't know if it's compile transpile to Shea scheme. Is that a thing? Or is it like different
that's right.
backends that you can go to?
Yeah, so Racket originally had a backend that was written in C, and it had it was like had a JIT, but it wasn't like an optimizing JIT. It was just it would compile functions on the fly from bytecode. And these days, for a variety of reasons, like a number of years ago now, probably almost 10 years ago now. God, it's been a long time. But it now runs primarily on the SheScheme backend because SheScheme was open source, and SheScheme is just a little bit more of a more sophisticated backend, and that compiles to native code. So everything is actually compiled to native code, although in a very different way from if you're used to a C compiler or the Haskell compiler. When those compile to native code, it's like you run the compiler and it spits out a native binary. That's not really what's happening here. Racket does all has its own object format, its own code loading, but it is ahead of time compiled to native code. So it's executing directly.
I've heard really good things about at least the speed of this Shea scheme stuff, so that's why.
Yeah, I would say that, in my opinion, it's a little overstated how sophisticated SheScheme is. When it was originally being used in Cisco, because Cisco was the company that was funding it for a long time, my understanding is they were writing pretty simple straight line code where it was it was like a decent compiler. It was certainly a better compiler than many scheme implementations, but it's definitely not like a super sophisticated optimizing compiler. It's not going to win any fights with a C compiler or GHC, but it is quite passable. And I certainly find it to be perfectly sufficient for all of the code that I am writing in Racket.
I think our main contender is Node and JS, right? Because we're going to be talking to Fabrice, who's working on the Chess backend for PureScript, and the goal is to have a fast backend for PureScript. I think that
makes sense.
I'm curious about as well.
Yeah, cool. Yeah. I think there's a lot of things in Racket that make it in some way slower than it could otherwise be, which I might even get into that a little bit when we are talking about this, but that's okay.
Then maybe one thing to tie it back to what you said at the beginning. You said it's your favorite language, and you worked on GHC, and I guess if you ask a lot of functional programmers, they'd probably go with Haskell. You said you don't like the syntax too much, so you said you like the documentation and that a lot. So I'm curious, is it just that? What makes it so that you like it so much?
It's a good question. I should be clear. I also do really like Haskell. I never really write Haskell for personal projects. I think there's a variety of reasons that I really like Racket. One of them is that I find Racket, it is so easy for me to just start writing a Racket program. I can just open up Dr. Racket, which is this goofy little IDE that they have, and I can just say, hello world, and run it, and it prints out hello world. And if I want to do something that involves graphics, I can do this. Oops. And oops, I want filled rectangle. And then I have something that has graphics. So like there's a lot of libraries. I can get something that's going super, super easily. I guess it probably fills a similar niche to what a lot of people would use like Python for. I certainly use it for all my scripts. There's not a lot of, you don't need a project to do anything. And so it's just really easy to get started. But then the other thing is that there are a lot of things in it, a lot of libraries that I find really useful for I find them pleasant to work with. The documentation is excellent. And I do love that it has this macro system. Like if there's something that I need to syntactically abstract over, it's really good at that. And when I'm working on something by myself, when it's just a personal project, I can keep everything in my head well enough that like I don't really feel the need to have static types. Like when I really value static types is when I'm working on a project with somebody else, and I feel like there's just no way that I'm going to know the whole project. That's just not going to happen. Whereas with this, I can generally keep it in my head, and there's some features that make it so that the lack of static types isn't as bad as it feels in other languages. But I think a lot of it is just, I guess one other thing is that I've done a lot of things where I'm interacting with a SQLite database, and there's like I've written some libraries to make it really easy to do that. So it's just, I find it like I value my time, and when I'm getting paid to work on something and I want it to be like good and maintainable forever, like I like that Haskell kind of encourages me to put a lot of effort into it. But Racket is something where like I can get something working that I'm happy with in a lot less time.
Yeah, nice. I think especially I like the doctor a lot. I think that's pretty cool. That
Yeah.
goes into this direction of this. I don't know. It's also probably 15 years old by now, right? This whole Brett Victor thing, right? I think there was Haskell for Mac at some point, which kind of went in this direction. But I think a lot of the time it's just some tech demos, right? And then you have a thing
Yeah.
can do 2 or 3 things. But this, I think you also said, is used for teaching, right? So I suppose that you can
Yeah.
do kind of the fun stuff, right? Seeing the rectangle, right? Like even if you could say that in JavaScript, you can do that quite easily, but it's even there, right? You have to stick a canvas somewhere first, and then you have to get this context and all that kind of stuff, right? So it's all like
Yeah.
weird stuff.
Yeah.
Okay, yeah, it's
Totally.
cool.
You wanna
Cool.
dive deep into the project?
Yeah, absolutely. So I think what I want to do is to start by just showing off what this actually is. So if you never actually played Picross before, or Nonogram, Picross is like a Nintendo brand name for nonograms, but I think it's a little bit more familiar to people. The way that it works is you have a puzzle, and there are clues on the sides of the puzzle. Basically what this means is if we look at this, you look at this row, which has this 1, 7 in it, that means that in this row, there's going to be one filled in tile that is only one column wide, and then there's going to be a span of 7 filled in tiles, but it can go anywhere. But it has to be separated by at least one space between those 2 blocks. So the way that you normally go about solving a puzzle like this is, for example, for this 6 row right here, we would say if it were to start all the way at the left, it would extend out to here. And if it were to start all the way at the right, it would extend out to here. So these 2 tiles in the middle have to be filled in because there's no way that you could place it such that they wouldn't be. And you can do the same thing over here. You can say at this point out to, like all of these would have to be filled in if you count it out. And eventually, as you solve the puzzle, and here I'm just using a feature that's automatically solving it for me, but it will eventually make some kind of picture. And to be honest, I have no idea what the picture is for this one. Maybe it's a piece of bread. I don't
So
know. But
are the numbers then order, right? So if it says 1, 7,
yes, right.
okay.
That's right. So let me now actually open a sort of a more complicated one. So let's do puzzles. I don't really, it's a very programmer UI project. I don't have a lot of things. Like I don't have any way to select a puzzle via the line, but if I open some larger one, here's a much bigger puzzle. And so I have this, basically I have I'll go over a few of the features, but I have this ability to make the computer solve the puzzle. Actually, I'm hitting the wrong buttons. I can make it solve it incrementally like this. So that's similar to how a human would solve it. And to be honest, I also don't really know what this is. These puzzles are from the Switch Picross games, which once you solve them, they become colorized, which makes them a lot easier to see. But I also have a feature where you can go into, say, some website that has some puzzles, and I can do this hack to extract their puzzle format, and I can then load that puzzle into the game and just solve it, and there's a much easier to read particular picture. I find that those ones are a little bit more fun. And there's tons and tons of these puzzles. There's lots of them available. But the real reason that I made this project, because there are like this website has its own little interactive user interface to these as well. So why did I make my own custom one? There's a few reasons. One of them is that there's a lot of nice features. This one is based on the Picross S games for the Nintendo Switch, which they have a lot of really nice features. So for example, if I launch, oops, not that, launch the first one that I had open again, there's a handful of nice features. Like so as you fill in a column, for example, it will automatically gray out the numbers that you've completed, and it will do that based on actually solving the puzzle, not based on it knows the answer. So, for example, even if I were to do this incorrectly, it will still mark this one off and it won't mark it as a mistake, but it will tell me which columns have contradictions in them. It's not cheating. But then it also has a handful of features, like I can hit, that's the show FPS button, sorry. I can hit this button and it will show me what the mistakes are if I want to cheat a little bit. I can have it automatically solve the puzzle for me. And then there's one additional feature, which is there's two additional features. One is that it's multiplayer. So you can connect to it. You can configure to host a server and somebody else can connect to it. And so I've been doing that too. Basically, I wanted to play Picross with my girlfriend while we were long distance. She won't be long distance anymore, but we were long distance at the time. And so that was very nice. And the other reason is that this supports, if I hit this button, it will turn this into a mega Picross puzzle, which is this kind of variant of Picross that only exists in the Switch Picross games, which is more complicated. And I feel like I probably don't need to go into the actual rules because that's not really what this is about, but found it really fun. And there were no implementations of mega Picross anywhere on the internet as far as I could find. Yeah, that's the idea. Any questions about that?
Did you just turn it into a mega Picross from a regular one?
Yes. Yeah.
Oh,
So
okay.
I guess I can explain a little bit about the way mega Picross works just to give a super high level overview. So the basic idea is that, like in Picross, in normal Picross, as I just explained, if you have a 2, then that corresponds to 2 blocks in that row that are touching each other. And when you have in mega Picross, like if we look at this column here, then each one of these sort of larger mega numbers, as they call them, they work the same way as normal Picross, except that they have to span both and they can happen in any shape. The 4 could be like this. That's a legal pattern for the 4. It could be like this. It could be like this or anything like that, but it has to span both. And then the other rule is that if there's a single line clue, like this mega column right here has, or actually let's look at this row here. So it has to have a 3 in the top row, and that works just like a normal single line clue in a normal Picross puzzle. But the additional rule is that in a mega line, that is a pair of rows or columns that have mega clues in them, then if there's a single line clue like this 3, then there can't be anything in the opposite. It can't touch anything that's in the opposite line. So it could go here. And if it went here, then there wouldn't be able to be anything there. So those are essentially the rules to Mega Picross. So it turns out that if you know the solution, if we solve it, and it is a normal single line Picross puzzle, then there's something that you can do to basically take the solution and turn it into a mega Picross puzzle by just going backwards from the solution and picking a random set of rows and columns to turn into mega lines and making sure it's still solvable. So in order to do that, I have to have a Picross solver, which I do. It's quite extensive, but as a result, then I'm allowed to load up any random puzzle, turn it into a mega Picross puzzle, which I find a lot more fun. And yeah, that's how that works.
Nice. Is there anything more than mega, like some hyper, where it spans more than 2?
So I've never seen anything more than mega Picross. I think it would get very complex to solve and even more complex to like generate and check. The other thing is that as it currently stands, even in Mega Picross, there are some situations where I think the only way to solve it is to do brute force to check a bunch of different possibilities. I would imagine that would have a combinatorial explosion of different possibilities. And Mega Picross is already complex enough. That said, there is another more common variant, which is called color Picross or color nonograms. And that is where instead of just being black and white, the clues are colored as well. And I've never seen anybody do mega color nonograms. I think in part because it wouldn't work quite as well, because if there's different colors, they wouldn't be spanning multiple. It would probably actually in some ways make it easier, but those are the main variants of nonograms that I'm familiar with.
Very nice. I have one more thing, which I don't know if you've even thought about this, but I always wonder how people come up with the puzzles themselves, right? So you could have maybe something where somebody just draws some pixel art. Is there only one way to describe a given Nonogram for the pixel art, or is it? Oh, okay, nice. Okay, that
That is
exists.
a great
Obviously.
question. That's a great question. Now, something that's very funny is that I only found out about this project after I had written my Picross implementation. Something that I find very funny is that Paul Stainsiver is also a programming languages person. This is written in Rust, and he is, I don't know if he still is, but if you look at Paul Stainsiver, he's published papers on Racket stuff. Very funny. But anyway, I found this puzzle, and he has posted some puzzles on this website, which is how I found out about this. And some of them are really good. They're really nice puzzles. But so one of the ways that he did that is he wrote this tool that is for coming up with for designing a Picross puzzle. So we can design a really simple one right here. And so if you just design some arbitrary picture, it's not necessarily going to be fully determined. We could then say disambiguate. I don't actually know exactly how this tool works. Let's see, solve. I haven't actually figured out exactly how this works, but there's something here that's saying if you were to place a tile somewhere, then I guess, I don't know. I haven't taken the time, but this will then generate a puzzle, and I'm going to assume that, let's see, I'm sure some way to have it automatically solve. Anyway, there's a tool that will help you design a puzzle that is unambiguous and has a single solution. There are some puzzles that people publish that, like this website, I believe, only accepts puzzles with a single unambiguous solution, but there are some other websites. There's WebPBN, and this website, I think, has some puzzles that have multiple possible solutions, but I think it's generally considered bad form to do that. This website is cool because it has a let's see, and solve. Sadly, this person, Jan Wolter, is no longer alive, passed away a number of years ago, but has a really lovely website on Picross solvers, Nonogram solvers, and has this set of test cases, which was very helpful when I was working on my implementation.
Yeah, that's very cool.
The Switch game, it supports multiplayer, but it's only local multiplayer, so you can't play it networked. I wanted to have something that was like the Switch game, but I could play it over the network, and she could run it on her computer, and I could run it on my computer, and we could play together. So that was like the main motivation for me.
And how do you play this together? Do you discuss stuff, or do you just say, I take the right half, you take the left?
So how it works when you do this. So I'm gonna run one implementation, and then let's do next another one, another process. So like you can see on both screens, like here's my cursor, and this one has a red cursor. And so we just do our own thing. And usually if we're doing like a larger puzzle, then we are just like looking at different rows or columns, and whoever gets to it first gets to it first, and that's fine. And sometimes somebody makes a mistake. There's some features that I've been wanting to add to keep track of like who placed which tiles, both because the Switch games do that. You can say at the end, you can see like how many people placed the most tiles, so you can get competitive if you want to. But I've also been thinking it would be fun to have a feature that like says if somebody made a mistake and then you discover that somebody made a mistake, you can say who made the first mistake too. Because if you make a single mistake, then you'll like end up making more mistakes later, and so it can be hard to know who originally messed up. But haven't done that yet.
Yeah, that's nice. Okay, thanks.
All right. So the theme of this is fun functional programming, and I definitely feel like I was recently working on this, and it's a perfect example of that because it is something that it is done. It's not entirely functional, but it's definitely, I think, mostly written in a functional style. And for example, here in this particular core module, I have a bunch of data type definitions for here's what the board is, and the board is, and so Racket so there is typed Racket. I don't really personally ever use typed Racket for a variety of reasons. The type inference is not good enough for me, and it's a little restrictive, but Racket does have something called contracts, which are like dynamically checked types. It's a little bit more complicated than that, but the basic idea is that we have things that you have to get used to the fact that in Scheme everything is done in prefix notation, but this is a function contract from word is how in the Lisp world we pronounce, or word P, depending on if you're talking to a common Lisper or a schemer. But I've always heard these predicates pronounced word which is a predicate which returns true if something is a board. And so this is a contract, which you can think of as a type that says this is a function type that accepts a board and returns a natural number. And so this is the sort of module that defines all the data types, and we define things like the board and clues and things like that. And it's all done in a nice functional way, so there's no mutation. It's if you do board set, it does a functional set where it returns a new board when you're done. And in some ways, you might think, okay, this would not be super efficient necessarily because we're doing all these copies. But the board doesn't actually change all that much because it's only going to change when somebody actually makes an edit to it. So it's totally fine to do a lot of copying, and you're only copying a single row or column. Everything else is updated persistently. And so that works out. When we get into the solver, then that uses some mutation because that would be very expensive to do entirely in a pure functional way. But yeah, so this is just defining some basic data types. And then when we look into sort of the main module here, then if you've done anything with the Elm architecture or React Redux or something like that, then this is written in a very similar way where we have some just functional state of the game and we don't mutate it. We just have some functions that basically process an event. So we take some client state in, and this produces some list of actions to perform. And some of those actions then get sent to over the network to other people that are connected, and they function down here, perform action, which takes a client state and an action and returns a new client state. So it's all done in kind of a usual functional way. And I think that definitely has made it very easy to implement certain things. Like when I wanted to implement something to say, I guess one feature I didn't demonstrate is that there's a hint feature where you can say, oh, I want the game to tell me a row or column that I want to look at. So here it's highlighted when I hit the hint button, it's highlighted one row or column that it thinks I can gain more information in. And the way that it's actually doing that is it's running the solver internally, and then it picks the row or column that the solver was able to make the most progress on in a single iteration. That's very easy to do when everything is immutable and you don't need to worry about all that state management. You can just run it, do the analysis, throw the new board away.
Funny. That's the column that I used when I tried to solve that one, when I was playing around with that one. Because that's the one that takes all the 10. It's kind of easy one.
Yeah.
This is a comment, right? That's just a comment for you with
yes,
the type.
That's right.
This is not conventional or anything, or is it just...
So this is idiomatic, but it is just a comment. So there is something which I guess I can point out. There's something called typed racket. And typed racket is basically the idea is let's try and take those comments and make it so that they do something. They actually are checked. And so if you like types, you can do that. I have used typed racket. I think it's very cool. It was like a very early gradually typed language. One of the earliest to really build out a gradual typing story. And I think one of the really cool features about it is that it has sound interoperation with dynamically typed Racket. If you have a typed program and you use it from typed code, then there's no runtime checking of the types. But if you use it from untyped module, then at the boundary, it will verify the types or even wrap values in proxies, like for functions that will check the inputs and outputs to make sure that the type system stays sound, and that allows it to do optimizations. Whereas like in TypeScript, it can't optimize your program assuming that the types are correct because they're often not. It's not a sound type system. So there's lots of cool stuff in it, but I just find that it is a little bit restrictive. And one of the reasons I was working on Hackett for a while is I wanted a typed language. I would still like a typed language in the Racket ecosystem that is more like Haskell, but it'd be a lot of work, and this is fine for now. So yes, this is just a comment, and it's for my own personal edification.
You have multiple modules or multiple files. Can you mix languages like core in typed and sprites and not typed, for example?
Yes, you definitely can. Yeah. When you write, like you can import a module written in any language you want, but you can just write, you can change this hashlang at the top and pick any old language. And of course, like the interop story between them will vary depending on what the semantics of the language is. Like, for example, Racket has like a hashlang lazy, which I might actually have installed. I don't have it installed, but there is a hashlang lazy, and that is like lazy Racket. No one really uses it. It's mostly just like a proof of concept. But in that case, like if you import something, then of course it's going to have these funcs in it, possibly, which of course, like if you're using it from dynamically typed or normal untyped Racket, then it's not going to work like directly because you have to manually force the funcs. But aside from that, like it mostly just works. You don't have to worry. It's not like you have to have some FFI or something like that. It's like Java Scala interop where it just works.
So the comments that you have on top of the syntax that you would use with typed Racket, but you just essentially don't have it on, right? So it's just for yourself that you're saying, okay.
Yeah, that's about right. Typed
Yes.
Racket it's not exactly the same as typed Racket. Typed Racket has slightly different syntax, but it's about the same. And that's because these are actually contracts. So Racket has contract. Here are the documentation for the contract system. I don't know why it keeps resetting my Zoom. I guess because I'm on localhost or something. But anyway, this is the syntax of contracts, and the typed Racket type syntax is intentionally designed to mirror the contract syntax. So this is using contract syntax. Or C is a union contract, which accepts either a integer point or the value false. So yeah, things like that.
And those are these contracts then checked at runtime if you have these comments?
So they are not just, these are things that I'm not actually exporting from this module. But if we go back to core, then you can see at the top of here, I'm exporting these with contract out. I actually have maybe contract out, which is a little macro that I defined here because I found that they have a runtime overhead. And for this particular project, I found they had a noticeable runtime overhead. So this is against the spirit of using contracts, but I have a switch to flip them on and off. But basically what this is doing is it's exporting all of these values with contracts attached to them. So these will be checked. So if I flip this on, then it will check. So when I'm debugging and developing, then I switch this on.
Kind of like your self-built dev build that you can have
That's right.
on.
That's
okay,
right.
Okay, I see. Nice.
That's right. Yeah. And the nice thing about contracts is that they'll keep track of if you have some higher order function, for example, and with the higher order function, the place where the error occurs might not be within the scope of the function, right? It might be that it returns a function, and then at some point that function is called and it violates its contract. The contract system will keep track of that, and it will still give you an error message that describes the function that made the mistake, violated the contract. So it's a little bit nicer than just having a stack trace in that regard. It's a little nicer than just having assertions. This is called blame. If you are interested in investigating, it's very cool. They've done a lot of really good work on it, and it works very nicely. I would still prefer to have static types, but there's some things that you can do with it that it supports dependent contracts, which you wouldn't necessarily be able to do as easily with most type systems. But that's easy to implement when it's all just done at runtime anyway. So lots of cool stuff.
Cool.
All right, so I'm not going to go too much into the detail of the specifics of this particular code here. I think it's mostly just with implementing all the game logic. And this is implementing just the protocol logic and the client server stuff. But there's a few things that I do want to highlight. And in the spirit of functional programming, the first thing I want to talk about is the solver. So if we look at the solver, this is all done functionally, and we have just some nice ways to basically say there's sort of two entry points to the solver, and they take a puzzle, and a puzzle is just a combination of a board state and the clues, where the clues are the little numbers on the sides of the puzzle. And then we produce a board analysis value. And if I take a look at solve core, I can take a look at what board analysis is. Just say, oh, I guess I can just switch this. All right, here. So this is, so Racket, in Racket, a struct is like just a record containing these two fields. So it has row analysis and column analysis, which are themselves axis clue analysis, which are arrays and line clue analysis. So this is basically like we have some analysis for each of the rows and columns. Now, what actually is analysis? Analysis is what happens when, if you have a partially completed puzzle, if you have a partially completed puzzle, then the analysis is basically saying, first of all, is there an error in the puzzle? And if not, which clues have been completed? So in this case, like in this column, the second and third clues have been completed, they're finished, but the first one is not. So if we look at the code down here, we've got somewhere in here, clue analysis is either done And so in Racket, like in Lisps, if you have a little tick before something, that's a symbol literal, which is like a string, but they're all interned. It's just used as essentially like in Haskell, you define a like ADT, an enum type, or in some other language, like in TypeScript, you would use a union of strings. In Rackets, that's idiomatically done using this union of symbols. So it's either going to be the symbol done or the symbol pending, where done is a clue that has been completed, it's grayed out, and a pending clue is one that is black. And so then we also have like a full-blown clue analysis is either going to the line clue analysis. So this is the analysis for an entire line of clues, which is like the sequence 151. So that's either going to be a line clue analysis result, which is, I guess this is now a little more complex by the fact that I also have the hints feature, but it's essentially either a sequence, an array of either these. There's lots of indirection here because of all the different cases that this has to handle, but it's basically a list of these done or pending values or an error. So if you make a mistake, like if we were to say this was 6 long, then it will detect that this is a mistake and it will highlight this in red. And whenever there's any mistake, then the whole line is in error, so we just return error. And so if we take a look at single line solver, basically the way that this whole thing works is in order to analyze which things are done, you essentially do have to write something that will solve a line at a time, doing all the types of logic that a human being might do. So in here, we have a few sort of test cases, which I think will help to illustrate the way that this works. Here, for example, if we have a line and the clues are 1, 2, 1, and then you have a board line, which is all empty, then after solving, it will return a solver result, which is full, cross, full, cross, full. And that's because 121 can only fit. This is the only way that it can fit in this particular length of line. And it will return true to say that it's fully solved. And so then there's some other examples where it can make a little bit of partial progress. So like here we have 1, 3, and we're giving it something that's already partially solved because that's what the actual input is during the game. And we get back something that's almost exactly the same, but it's learned that it can place a cross right here. And the reason that this is important is that then when we actually do the line analysis, the reason that this is necessary and the reason we can't just do the naive thing of what if we just started from the left and okay, there's a tile here, and we can assume that because it's, or actually a better example is this 322. We could start from here, we could say, you know, this here we have a 2. This is not a good example. I need to move this. Maybe this puzzle is just not big enough. Are there any? Let's do, okay, this column right here, this one. Like this 2, we don't know which of the two clues in this column it could be. It could be either one because we don't know. So in order to do that, we have to, in order to learn that, we have to solve the puzzle, and then we can match up what the user has placed on the tile to what we know, and then we can use that information to decide which clues have been completed. And so because of the fact that this is all just like a nice little pure function where we can take the state of the game in and the clues and get some result out, it's very easy to write all these test cases. And believe me, there were absolutely lots of, as I was working on this, lots of subtle issues that I ran into where it wasn't working quite right. And it was very nice to be able to just pull these out and have some simple test cases. The solver itself is quite complex, and I'm not really going to go into it because it's actually not a super great example of, I think, functional programming. It does do a lot of mutation. There's a lot of banging on mutable vectors just because otherwise it would be horribly inefficient. But I think the one thing that I will say that's interesting about it is that the basic strategy is that we essentially create, for each clue in the line, we create a separate vector that is like how much we have solved the board. It's like each little clue gets its own separate board, and then we solve just that clue relative to the other clues. So it's like for this particular line right here, if we did something like this, then if we were just looking at 3 lines, one of which is for the 3, one for the 2, one for the other 2, then we would know that for this final 2, its line would look like this, and then the one above it would look like this, and then the one above that would look like this because we have to have the 2 here and then a space before the 3 goes there. And so I don't know if this really makes sense, but the idea is then like this row here is what the board internal solver state is for the 3, and it can only go there, and then these can be crossed out, and that means that we can fill in like this tile here. So there's a kind of iterative process where we work through things and fill in things based on where they have to go. And it's how you would expect a solver for this to work, I think.
I think I'm not 100% sure I correctly understood the thing where you said when you have the 2-2 case. So you say you might see that you just essentially don't know which of the two it is.
That's right.
And then did you say that you solve it internally and you see which one you solve first? And then you,
yeah.
yeah.
So let's see, is there...
Because I was just wondering if you could make a mistake as the user.
Yes.
You kind of get the other one, but maybe that's no problem anyways.
So if you, here, that's actually a good point. If I solve this puzzle and I tell the computer to solve it for me, I know that the correct positions of the 2 and the 2 are here and here. So let me remove an X so you can see the actual grid. So they're here and here. So if I clear everything again, if I put a 2 here, well, okay, it actually is illegal for that particular row. But if I put a 2 here, or even like here, which is not, I don't think that's correct. And in fact, if I hit this, it will tell me, yeah, it's not correct. But this hasn't complained. This isn't complaining yet because it's not cheating. It's not looking at the actual solution. The solver does not know the actual solution. It's just trying to analyze what you have played. So if we look at like a lot of online Picross implementations, you'll see is that if I put a tile in here or whatever, then I can cross all these out myself, but then I have to go in and cross out the numbers myself, like you were doing it on pen and paper or whatever. And the Switch version automatically crosses things out for you, which maybe you could say is cheating, but I think because it's only doing it based on reasoning that you could do, I think the reason they did it is because the Switch games are done with a controller. So it would be really annoying if you would have to scroll back up with your controller to the line and cross out numbers as you're doing them. But it's also really nice because when you're doing a really big puzzle, you end up spending a lot of time just like counting to figure out, okay, which of these clues is this one? And I just think it saves some busy work to have the machine doing it for you because, again, it's not leaking information. It's only using the information that you've given it. But if I do something incorrect, like if I put this here where I have 3 tiles in this column, then the solver will detect that this is now an unsolvable column. There is no valid solution, so it will highlight it in red and say, you have made a mistake. Now, in the Switch version of the game, there's different levels of assist that you can use. One of them is where it will only cross out numbers, and if you make a mistake, it will just tell you nothing. It will still technically tell you something because it will mark that row as nothing has been completed anymore. So if you're observant, you can notice that, but it won't highlight anything in red. And then there's a level where it will highlight any mistakes in the way that this does by default. And there's another mode, which I can turn on here, I think by this one, where it will show all hints all the time. So if you're like learning how to play Picross, it will just highlight all of the rows and columns where you could make progress in them. And so it tells you, here's the rows and columns that you should look at in order to make progress on the puzzle. And so it's useful if you're still learning how to play or whatever. So all of that, oh yeah, go ahead.
But like for this particular case, the 2-2 row column again, you could place it just on either side of the green thing. Which one do you gray out then?
I mean, so in this case,
one below this, I think.
Oh, one below this?
Oh, it doesn't even, yeah, I was thinking, because now how do you know which of the twos?
Right, yes. So the rule is that it will only gray something out if it's unambiguous. And so in this case, because it doesn't know, it won't do anything. But for example, if we then put an X here, then it would gray out that top one because the top 2 couldn't fit here or here, so it has to go here. So it's just using all the information that is available in the line to determine. And in some cases, I probably even have some test cases, it can get quite complex where this is a test case because it's really big. It was from some actual puzzle that I had been playing at the time. And I noticed that the analysis wasn't working correctly. So I pulled that out as a test case. And this is some complicated line where we have 2, 2, 1, 1, and we had empty cross, full, cross, empty, full, empty, full. So we have all this information here. And the correct result was to say that like this is the first 2 is done. And the reason that we're able to know this is that we can infer that even though there is this empty slot at the beginning of the row where the first 2 could go, we actually know that it can't be this first two, because if it was, and this was the second two, then these tiles that are already filled in would not be able to be covered by the 1-1. So this is an illustration of like how complex it can get, where in order to do it correctly, like, and a human will, once you've played a lot of Picross, this just becomes second nature. You're not going to be thinking about it in these terms. It's just going to be obvious. But to make a computer do that, you have to actually make it go through and solve everything. And so it ends up getting pretty complicated.
I'm just curious, how's the mutations done? Is there some specific syntax specific thing you need to do, or you just mutate it, whatever?
In this case, I'm using mutable vectors, which are just like a mutable data structure. And by convention in Racket, things that do mutation are functions with a exclamation mark at the end. So this is vector set bang, and that means that it is vector set bang does mutation of a mutable vector. And Racket has both mutable and immutable vectors. And in fact, I'm using a lot of immutable vectors in this project, so I actually introduced a little tiny helper library called array, which is just to make it a little less confusing. I'm calling mutable vectors arrays in my code. So it basically just provides all of the immutable vector operations, but re-exports them with the name array. And therefore it's clear when I'm using mutable vectors and when I'm using immutable vectors. So when I say in array, I'm using an immutable vector. And when I'm saying in vector somewhere in here, then it's using mutable vectors. The reason that this is using mutable vectors, like in theory, you could do this with some persistent vector, but it's just not actually, like, you wouldn't gain anything from doing that really, because it is, the information gain is monotonic. So that is to say, as you solve the puzzle, you're only ever making correct, like you never guess. So you are just like gradually gaining more information. And so you don't need to, it's not like backtracking search. So it just kind of makes sense to use mutable data structure here. But even though this is using a mutable data structure, like aside from that, it's something that wouldn't look out of place in a Haskell program with a mutable vector or a state monad, where essentially we just have a solver, and if I scroll all the way down to here, we have this core loop of the solver, which is called gain information to fixed point. And this in Racket is called named let. It's like a little syntax for basically in Haskell, it would be when you write let go and then you call go immediately. This is doing the same thing, where you're just defining a little like inline function and calling it immediately. And it can have arguments, but in this case, it doesn't have any arguments. So we're just writing a little loop, and it's a tail recursive loop. And so we just iterate repeatedly until we didn't, and we keep track of whether or not we gained information on each version of the loop. And if we did, we'll go again. And then once we've finished, we didn't gain any information, then we know that we've reached a fixed point and the solver is done. So that is the core idea. And there's just a few different strategies that it uses. Something that's a little bit interesting is that the most efficient nonogram solvers, if you go to this person's, I think I don't have it open. Oh, I do have it open. This is an overview of solvers, and there's some page here, yeah, which kind of talks about implementation details of this particular solver. And one of the things that I found interesting when I was reading this is that the most efficient solvers generally don't actually, they're not complete. They are not, so the way that when you write a solver normally, what you're doing is you are writing a line solver, which just looks at a single row or column at a time, and then solves it just based on the clues. And there are types of reasoning you can do in these, in nonogram puzzles, where you are like using multiple lines at a time, like a intersection of a line and a column, although it's not usually necessary to do that. But it just turns out to actually be more efficient in many cases to write a very fast but incomplete line solver and then have a very smart guessing algorithm, which is interesting. My algorithm is not that way. My algorithm is not just trying to solve puzzles as quickly as possible. It's just trying to analyze puzzles as you're playing the game. So it's not the most efficient way that it probably could be written, but it's fast enough for my needs. And it is, I think, the standard Picross solver that I have, I believe, is complete. I believe that it will do all, it will obtain all information that you can possibly get from a single line at a time. The Mega Picross solver is not 100% complete. There's a few cases where there's technically information that a human could figure out from a single line that it doesn't. And that's because the Mega Line solver is much, much, much more complex. So just as a initial pass, this is a 1300 line file just for the Mega Picross solver, whereas the normal Picross solver is only 600 lines. Of course, a lot of this is test cases, but still, it's a lot. And
I mean, logically it makes sense, right? There you look
yeah,
at 1 line, and here you look at 2 lines, so it's double the code.
that's right. That's right. That's right. And it's not just that you're looking at more lines. It's like it's that when you are looking at Mega Picross, because of the fact that this 8 clue here, it can have many different shapes. This is a valid 8 clue, but this is a valid 8 clue. And like that's a valid 8 clue. And there's lots of different potential weird shapes that you can have for some of these mega clues. And therefore, like you can't just exhaustively check everything, because once you get above small numbers, like you're going to end up with this combinatorial explosion of different shapes that the things could come in. So you have to be a little bit smarter. And so the way that this works, like I have a bunch of helper functions, and this core module is itself another 1,300 lines. It's a lot of code. By the way, this project, there's no LLM generated code. This is all handwritten, which I think is like I do use LLMs as part of my job. But first of all, I found that they are just not very good at this particular problem. I think there's something about like there's probably a Picross is, I'm sure, not really in the training data much at all. And the other thing is that it's very geometric, it's very visual. And often I found that just as an experiment, after I'd written this, I was going to give it a try to fix a bug, have it fix a bug, and it was terrible. It's just completely worthless. I also intentionally chose to write this all myself because I think it's fun. I like writing code. I think it's enjoyable. And I think that it's like in the same way that somebody who's really into woodworking would make a table themselves, even though they could just buy a table from IKEA or whatever. I think it's nice to enjoy the fun of making something by hand.
Yeah, that's interesting, right? Because I always feel like you have a lot of people who, at some point, they're like, I just want to live in some kind of commune, right? And the thing that I think is the problem is that everybody always wants to do the woodworking. So you can't have a commune. Like you
Yeah.
said, it's not that everybody wants to do the woodworking and make tables or whatever, right? But like you said, if you buy it off of IKEA, I don't know who has ever told me that it was a lot of fun to put up any kind of IKEA thing, right? So
Yeah. Yeah.
it's actually a
Yeah.
pretty good analogy, I think. But
Yes.
did you start this kind of, when did you start writing this? Because I was somehow assuming that you started this before LLMs were like
No,
a reasonable thing.
this I started just earlier this year. My first commit here was, let's see, first commit was February 21st. So was when I started working on it. And yeah, I was working on it for a couple months. I haven't been working on it the past month or two, but I'll probably come back to it eventually. But it's in a state where I'm happy with it. It does what I want it to do. And I'm relatively satisfied.
What were your favorite parts to write?
I think definitely the Megaline solver was a lot of fun. It's very complex, and I'm showing this comment because it's a good illustration of how complicated it is. Here's a case where these are just helper functions, which are used in the solver. And this is saying, so we have a function here, which is used to do two different things. It's used to bridge the first and last filled tiles in a mega clue, which is to say, if you have a line and you have filled in, like, let's see, let me open a mega puzzle. Let's do S1, something big. If I have some, let's say that I have some clue and it's like this 11 here or whatever, and I have something like this, and we determine that these two tiles are a part of the 11, then we know that this tile has to be filled in and this tile has to be filled in because they have to connect somehow. But we don't know about what happens in here because it could take any path to connect them. And it can't connect across corners. Corners don't count, so it has to connect orthogonally. And so in order to do that, we have to write some function that's scanning a region to figure out which tiles have to be filled in. And so we're analyzing the information or the board in between the two states. But then the ends have to be handled specially. So I have these cute little ASCII art diagrams that have examples, and I'm not going to go into the specific details, but it's quite complex. And there's just some fun data modeling involved in here. Like, for example, there's, I guess one of the cute things is I have something called a mega index, which is an index into a single line is just an index. It's just a single vector. But for a megaline, there are two different ways of indexing into it. We could say that we could have sort of a zigzag indexing pattern where this is 0, this is 1, this is 2, this is 3, this is 4, and so on. And so it's just like one long line that happens to be arranged in this particular geometry. And another way of thinking about it is as a combination of two values, one of which is a line index. So it's a combination of a 0 or a 1 for which line it is, and then an index within that line. And so I have this notion of a mega index, which is actually represented as a natural number. And it is that natural number corresponds to the zigzag indexing scheme that I mentioned. And the thing that's nice about this is that if you just want to iterate over all the tiles in a megaline, you can just do that by iterating from 0 to 2n, and it will just work out. But then I just do a little bit of bitwise math to say, okay, we can then get the line index or the tile index easily just by doing a simple bitwise operation. And that's cute. I thought that was nice. Something else that is cute is that because of the fact that in normal single line Picross, a tile has two neighbors, you can just use add one or subtract one to get the tile before or after. But in megalines, there can be up to three neighbors. There's less on the ends, but because there can be up to three neighbors, then I have these little functions which are just used to get the title, which is, I'm using the word affront because things that are prefixed with in Racket conventionally have a different meaning. And I found this esoteric, obscure word that means in front, but it's a single word and it's the same width as behind. Very cute. But then there's also, you can get the opposite tile. So the index of the tile that is adjacent to it. So if it's this tile, it will give you this tile. And so then when I'm writing all of these algorithms to walk through mega tile lines, then I can just write, like, given some mega index, give me the tile behind me and the tile in front of me and the tile opposite me. And that allows this all to be written a little more easily. It's not particularly elaborate, but I've always felt people talk about what is functional programming, and people have different opinions about that. I think some people think, oh, Haskell is functional programming, pure functional programming, static types. And certainly that is like a school of functional programming. I think it is a very nice one. Statically typed, pure functional programming is, especially like non-strict functional programming, maybe in some ways it's like the purest form. But I've always felt like a lot of what makes functional programming so effective is that really the idea is very simple, which is like you write functions on mutable data, ideally small functions, and then you compose them together. And you build up, you divide and conquer by using like inductive data structures that can be broken down, and you can just split up the problem into smaller subcomponents, and then you can write these functions, these little functions that you can then compose together to do some complex bit of functionality. And so I think even though this is like operating on mutable vectors, I think it still feels very spiritually functional to me in that I'm building up all these little tools in my toolbox in this module. And then when I go in to actually write my silver, then I have access to all of these nice tools where I can say, snap the Legos together in just the right way. And this is a really big, long, complicated function, but it's broken up into these little inline functions inside of it that do various different things. So even though it's not pure functional programming, it's not typed functional programming, I feel like it's still functional in style.
I think we need some rebranding eventually. Because we also talked to Gabriela Gonzalez, and she was talking about similar definitions. She was talking about the trees, right, and decomposing problems and composing and stuff. And that's what it's all about. And we're like, okay, that's a really good definition. And it matches what you mentioned.
Now that you've described how you've done it, that's how I like doing it as well, is this whole making things really small and in my mind understandable, and so that each individual step is easy, right? So I'm thinking, is that opposed to if you had done this with, let's say, C or something, right? Where you still operate on arrays, you'd have stuff which would be like, for your indexing, you'd probably do stuff like some index plus another index, maybe mod something else and so on. Whereas, and then you, as you figure that out, like you think about, at least I would think about, okay, I want a thing that is affront my current position or whatever. And then I'd have to, in my mind at least, like translate that to be, okay, that's my index -1 or whatever, right? But then I'd probably also have to check that I don't go off, right? And then I write that down, but I feel like I'm not documenting these hops that I have to do in my brain. And then, yeah, of course, at some point, like I've learned it and I can probably see it and do the pattern recognition, but it's not.
Yeah, I definitely think like building up these tools that have nice little names and do like sort of composite larger operation definitely means that I think in a lot of ways you're building up a little language. I don't know that I would just, people throw the word domain specific language, the phrase domain specific language around a lot these days. Sometimes I feel like maybe a little too freely, but I think it is true in some sense that like in a very broad definition of a domain specific language, you are building up a little domain specific language for talking about describing the problem that you are solving. And so then when you read the code, hopefully you can think about it from a little higher level and you're not worrying about all these little tiny details. And there are these different layers of abstraction, even within this little bit of code, just from having the big building blocks, which are made out of the smaller building blocks. So
does this lead us to looking at the OpenGL and then
yes,
the API interface you have on top of it?
and this can be pretty quick.
Now
It's very fast. So it's very, very performant. So even though it's this nice functional API, it renders very fast.
So you're building up essentially, if I understood correctly, you have layers, right? Which I don't know, maybe these are like textures or something in OpenGL, but so you stamp everything together, but you don't really do that yet, right? So you're just building up a structure.
Yeah.
And you're doing that every
Yep.
frame, and then you're sending that over to OpenGL to please put that on the screen
Yes.
now, and then you do that for each of your layers. Right?
Yeah. So like
Okay.
a serious game engine, this is what I would describe as like a toy game engine. It's very just cobbled together. I mean, it works fine for what my needs are, but a serious game engine, they usually have something that they call a scene graph, which is a data structure that contains all of the different entities. And of course, most games, they're pushing way more polygons and they're way more like the bottlenecks are going to be render time, whereas mine isn't. It's all CPU bound. The rendering is actually basically free and it's CPU bound and sending data over to the GPU and things like that. But so what they're worried about is they want to send as little data from the CPU to the GPU each frame. So they have their models, they upload those to the GPU, and then each frame they're just going to send over a little bit of data to say, here's where to render it, here's how to render these things. And as a result, they are keeping the amount of assembly on the CPU side to an absolute minimum per frame. And so I do a little bit of the same thing here. For things that don't change, I put them on their own layer, which is just like a separate GLDC context. And so it has its own vertex buffer. So I don't actually rebuild the whole vertex buffer and send it over to the GPU every frame. I only do it for the things that are actually changing a lot. Except I do a little bit more than that because my code it doesn't have to be, I'm rendering at 1000 FPS. It doesn't need to be more efficient than that. It's about as efficient as I wanted to make it. But so what I'm actually doing is these GL Pics that I have here are basically, you can think of them as, I'm somewhere in here, a Pict is something that it's like a function, and that draw function it basically accepts where do I have, this is just a normal DC. Somewhere in here I have the function that actually renders a pict. Oh yeah, here we go. This pict draw function, it takes a GLDC, which is a GLDC is basically just some vertexes or some vertex buffers, some big arrays that contain where we're going to stuff the vertices. It also has a reference to the texture atlas and the OpenGL texture and some OpenGL resources, a vertex array object and a vertex buffer object. But then it has the main thing that it's holding is these two big arrays of bytes and floats. And so when you actually apply the pict to a GLDC, then it will just fill in it will add vertices to those big arrays containing the information about the positions of the vertices, the colors, whether they're using textures or not. There's a whole bunch of things that get stuffed in there. And then when I actually render this, I have GLDC draw, where we then, if they're dirty, which is to say if the data has changed, if the vertices have changed, then we upload the new vertex data to the GPU, and then we just call GLDraw arrays, which will render it all out, render all the vertex data that we've slammed into those arrays and sent off to the GPU. And then it just uses these simple, the values that got stuffed into those buffers show up in our shaders here, which then runs on the GPU to actually shade in the triangles that we're drawing. Currently, the vertex shader is about as simple as it can get. The color, or the fragment shader, which is the thing that's actually shading the individual pixels, has a few different modes. We can render solid colors, we can render textures, which is something that we're going to be using from that texture atlas that we built. We can use a texture as a mask, which is like we're using the texture as an alpha channel and then coloring it. And so we can, if I go back to sprites here and run this again, these numbers here are used as a mask where we are coloring them based on the color that they're supposed to be in the line. So if they're supposed to be red, we'll color them red. We don't need to have a separate texture for the different colors. And then there's one final mode, which is, I can't really easily illustrate it actually because of the fact that as soon as I defocus, one of the cursors will go away, but there's a special effect that if you have two cursors that are in the same place on the game board, it will draw them cross-hatched, and I have a special shader mode to do that. And that's about it. Very simple, but it works well.
Did you, so you've shown that Cairo-based library first, right? Pics, and
yeah,
you've shown how it has all these shapes and so on. Did you build that too? So did you have to like, I don't know, you want to draw a circle, you make a circle out of triangles, and then you have to like probably decide how it should be?
That's a good question. So I did not do that. Currently, the only shape that my library is capable of rendering is a rectangle. And this is actually pretty common. Most 2D rendering is done this way, where like even your web browser or like your desktop environment is all being rendered as a bunch of textured quads, where a quad is a rectangle made out of two triangles. And the way that you get other shapes is rather than doing like a GPU rendering where you're like actually using geometry to make these different shapes. Instead, what you're doing is what I'm doing here, which is you build, like, for example, I have this particular like rounded rectangle. What I'm doing is I'm rendering that rounded rectangle on the CPU into a bitmap, and then I'm uploading that bitmap to the GPU. And so I'm actually just rendering a rectangle with pointy edges, but because I am using this texture, then it will use that to draw a nice smooth curve, but it's not actually smooth in the geometry. It's just pixel data.
Okay, so and I guess like you could then do stuff like 9 slices or whatever.
Yes.
You wanted to
yes.
change that. Okay, I see.
Yes.
That's cool.
Absolutely.
Okay.
Yeah.
Yeah, I like because I like that stuff, but I'm not good at it. So I have to vibe it because then I looked at, I don't know if you're curious about these things, but there's all this crazy stuff you can do in shaders with these signed distance functions, right?
Yes. Yeah.
So,
for Valve's font rendering stuff.
Yeah. So yeah, you can pack your fonts into an atlas and then use this other thing that does that. I have no idea how it does it really, but I suppose at that point, I don't know if Racket can do that, but then it becomes a lot of shader stuff, right? And then
at that point, it's just the OpenGL code. So Racket can do it because you can write arbitrary OpenGL, but yeah,
a string somewhere in Racket that is the shader. No? Okay,
right. Yes, that's what I currently have, and I could be in a file, but I only have these. I'm only using this shader setup. I only have this one vertex shader and this one. I just have a Uber shader, as they say in the business. So I just have them inline here, and they're not very big.
Yeah, very cool.
Okay. I think this is really fun. And do you have any further plans for this?
Yeah, so I do have some issues here of some things that I want to do. Mostly they're just minor improvements. Things like I think some of the biggest things that I would like to do is I would like to allow it to be like you can load puzzles without having to do this crazy goofy thing that I'm doing where I'm like going into some websites and opening the JavaScript console, copying it out. Yeah, I just want to have a puzzle format, something that makes basically things that make it a little more accessible. And I'd also like to add a few just additional UI features, things to make it more usable. I guess there's a reason I haven't really worked on it since April, because these were all the things that were just like, it would be nice to have, but I don't actually care enough to do it right now. But maybe someday I'll come back and do it. Something else that I have considered is that if I really do want it to be useful to a large number of people, then I'm really going to have to port it to run in the browser. And there is some way to compile Racket code to JavaScript. There's something called Racket script. I've never really used it, and I don't know how good it is. I feel it wouldn't be shocked if I wouldn't end up using this, but for now, I haven't really thought about it. I would worry about that once I got to it. But I guess the funny thing is that because there's WebGL, I could keep a lot of the rendering stuff the same, and it could still just render to a WebGL canvas or something like that, which is a little bit funny. That just happens to port over relatively easily in theory. I don't know if it actually would be in practice.
What about drawing your own puzzles, like you showed us before? Have you considered?
Yeah, I would really like to, like in theory, if I had infinite time and infinite energy and motivation to work on this, I would really like to have some UI similar to Paul Stansfer's thing over here, which I don't know how to use, but to have some interactive user interface for editing puzzles. Or I think in particular, some of the things that I would like to do is to have some way for it to evaluate how hard a puzzle is, and like some way to give feedback to a puzzle author to if they want to adjust the difficulty, either to make it harder or easier, maybe some feature to analyze it and figure out what changes they could make. But I haven't really thought about how I would go about doing that yet. It's just something that I've thought would be cool.
I was wondering about the mega solver. You were saying that one. I'm not sure if you said there are things that it cannot solve, or whether just the problem inherently is so that's not possible.
So there are some puzzles that are not line solvable, even standard Picross puzzles. That is to say, you cannot just solve lines like a single line at a time, so a single row at a time, single column at a time, and complete the puzzle. You'll eventually get stuck. So if you get stuck, then there are two ways to resolve this. One is that for some puzzles, you might be able to use some very fancy multi-line logic, and in some cases that can work out to help you make a little bit of progress, or you can guess and check. It's obviously not very satisfying to guess and check. So most Picross puzzles created by humans you're not supposed to guess and check. This is actually one of the reasons that I find kind of standard nonograms a little bit boring, is that they do tend to be line solvable, which means it's mostly just a mechanical process of filling them in, of just going through the puzzle and figuring out, oh, okay, I can make progress on this line and this line. And especially if they're really big puzzles, they can get really tedious because you're just hunting for the line or the column where you can make progress.
That's the most dramatic thing I've learned, that you're not supposed to guess and check. That's what I've been doing before, but I guess I was doing them as a kid, and I kind of learned this way. A bit similar to Sudoku, because you also there sometimes you have to guess and check.
Yeah.
But I was just doing it wrong this whole time.
Yeah, I think obviously it depends on which puzzles you are like looking at. Some of them might require, but I do think that like all of the ones that, first of all, I can say that all of the puzzles that I have, actually, maybe that's true, all but a couple of the puzzles that I've seen on nonograms.org, which is the main place I've been getting my puzzles, are line solvable. My solver doesn't do any guessing, and it can solve them. That said, that is because my single line, my like standard nonogram solver, is complete as far as I know. I think it will, if a puzzle is line solvable, it will solve the puzzle. The Mega Picross line solver is incomplete, which is to say there are some cases where it is theoretically line solvable, like you can solve it just by looking at, with no guessing, by looking at individual lines at a time. But I guess at that point, like it depends on your definition of what constitutes like guessing, because I think that in those cases, you do have to do some sort of exhaustive search to check different configurations of, like you have to do some kind of guess and check, some kind of factoring search to check different configurations for mega numbers. And the reason that I think that this is the case is that I played the Switch Picross games, and I've been trying to match what their solver does because I think it's generally very good, and I've never found it inadequate in any way. But something I've noticed while playing those games is that sometimes when I edit a line which has a mega number in it, the game lags for a split second. And The only way that I could think that it would possibly be like taking so much time that it's lagging is that they are doing for those cases. They're doing some exhaustive search that I'm not currently doing. So I've opted to not do that, but maybe at some point I will, or I've just been trying to add like kind of special cases that I think a human would do where it doesn't require any guessing so that I'm not having to do something like that. But it is a surprisingly interesting problem. For what it's worth, like solving nonograms in general is NP complete, but actual puzzles that are solved by humans are obviously not nearly that complex.
So you're saying when you solve them, you like it better when they are, I would just say tough, right? Not line solvable.
Yeah.
But
So
building a solver for that, you're saying like the guessing doesn't really feel right. And when you're saying it's this multi-line thing, I would think that you'd still be guessing just to ideally try the right lines in combination.
yeah, it all
Maybe a fancy
depends.
word.
For what it's worth, I do like Megaline Picross puzzles that are line solvable. I just find that the Mega Picross has more types of reasoning, even when you're just doing line solving, because you're considering there's more rules, right? There's more sort of, there are situations where I will find myself, and there are cases as well where I am using multi. In fact, I think this is more true in Mega Picross than in single line Picross. There are cases where you can do reasoning where you can look at the intersection of a row and a column, and then you can use that to gain some information, which my solver currently doesn't do. So because my solver doesn't do it, technically all the puzzles that I do, because it has to be able to solve them to turn it into a Mega Picross puzzle. They are line solvable. I know that they're line solvable, but I still find them fun because sometimes I can take shortcuts by doing. It's just a puzzle. It's a mental exercise. It's not about it being deeply challenging. There's a sweet spot for me where it's fun, but it's not like, if I want something that's really hard and intellectually stimulating, I'm not going to be playing nonograms.
Any parting thoughts, ideas out there that you want to put into the world? If you want people to try a Racket, if you want people to try something else, if you want to help with contributors?
Yeah, I definitely do think that I think Racket is lovely and it's very easy to install. You can go to their website, you can click download Racket. It will give you an installer, installs on your computer. You can open Dr. Racket. Very easy to use. So if you are interested in it, I would definitely encourage trying it out. I feel if you can get past the syntax, which for some people they can't, and that's okay. But if you can, there's a lot of really good stuff in there. And if you're looking for a language that's like Python, but it's a functional language, lots of immutable data, it's more efficient. Obviously, it doesn't have the things that people use for machine learning in Python. There's no NumPy equivalent, no SciPy equivalent. But if you're just doing it for scripts, then it's great. So I would definitely encourage people to try it out, and the community is very friendly.
Cool. Thank you very much.
Yeah, thank you.